Many important mathematical discoveries have begun with the study of patterns. In this chapter, we want to introduce an important polynomial theorem called the Binomial Theorem, for which we will set the stage by observing some patterns. You will use this again and again and again in the future of your math careers. Now, if you expand a plus b to the n power for n equals 0, 1, 2, 3, 4, and 5, here is what you get. So a plus b to the 0 power is 1. Remember, anything to the 0 power is 1. A plus b to the first will be 1a to the first, b to the 0, plus 1a to the 0, b to the first, or generally a plus b. A plus b to the second will be 1a squared plus 2ab plus 1b squared. A plus b to the third will be 1a to the third plus 3a squared b plus 3ab squared plus b to the third. A plus b to the fourth will be 1a to the fourth plus 4a to the third b plus 6a squared b squared plus 4ab to the third plus b to the fourth. A plus b to the fifth will be a to the fifth plus 5a to the fourth b plus 10a to the third b squared plus 10a squared b to the third plus 5ab to the fourth plus b to the fifth. It's going to keep going on and on like that. Can you observe the patterns and predict what the expansion of a plus b to the sixth will look like? Well, a plus b to the sixth. I know it's going to be 1a to the sixth b to the 0 plus, I'm going to add the 1 and the 5, and believe it or not, this is true, 6a to the fifth b to the first plus 15a to the fourth b squared plus 20a to the third b to the third plus 15a squared b to the fourth plus 6a b to the fifth plus b to the sixth power. What I'm really using here, I'm using something called the Binomial Theorem and also Pascal's triangle, which we'll go over in this chapter, in this section. And at first, you might not see the pattern that will enable you to find the other so-called binomial coefficients, but you should see it after the following exploration. Now, you need to take out your calculators here. Take out your calculators. It says compute 3C0. Well, 3, choose 0 would be 1. 3, choose 1. 3, choose 2. And then 3, choose 3. So we should get 1, 3, 3, and 1. Where can you find these numbers in the binomial expansion above? You can find those numbers in the binomial expansion above in a plus b to the third power. Now you should be able to see that in a plus b to the third. 1a to the third plus 3a squared b plus 3ab squared plus 1b to the third. Now, the expression 4 NCR and then braces 0, 1, 2, 3, and 4 tells the calculator to compute 4 choose R for each of the numbers R 0 through 4 and display them as a list. So to do that, we're going to do 4 choose, then we're going to do the braces, so second parenthesis, 0, comma, 1, comma. So that's what you're going to have. So it's going to give you the numbers 1, 4, 6, 4, 1. That is a plus b to the fourth power. Now it says do the same thing, compute 5. I'm going to cheat a little bit and so I don't have to write everything out here. So 1, 5, 10, 10, 5, 1. And that again would be an a plus b to the fifth. Now, by now, you're probably ready to conclude that the binomial coefficients in the expansion of a plus b to the n are just the values of n choose r for r, all the way 0 through all the way through n. We also hope you're wondering why this is true. Well, the expansion of a plus b to the n is really a plus b times a plus b times a plus b, and there's n factors. That consists of all the possible products that can be formed by taking one letter, either A or B, from each of the factors. The number of ways to form the product, A, R, B, and minus R, is exactly the same as the number of ways to choose R factors to contribute to an A. Since the rest of the factors will obviously contribute a B. The number of ways to choose R factors from N factors is N choose R. So one thing you always need to remember, if you have a to the third power, b is always going to be, if you're taking a plus b to the fifth, and you have a to the third power, it's going to be a to the third, b to the second. They're always going to add up to 5, whatever we need it to be. So, the binomial coefficients that appear in the expansion of a plus b to the n power, the values of n choose r for r equals 0 through n. A classical notation for n choose r, especially in the context of binomial coefficients, is parentheses n over r. Both notations are read n choose r. So if we look here at example 1, expanding binomial. Expand the binomial using a calculator to compute the binomial coefficients. So here's what we're going to do. We need to the fifth power. So what we're going to do here, we already did that. 5 and choose r 0 through 5. So those are my binomial coefficients. So that's what we're going to have. So when we do this, we'll have a to the fifth plus 5a to the fourth, b to the first, plus 10a to the third, b squared, plus 10a squared, b to the third, plus 5ab to the fourth, plus b to the fifth. And there you have it. Now for the seventh power, what we're going to do, we're going to do 7, choose r. We'll go 0 all the way through 7. And that's what we'll have there. It goes 1, 7, 21, 35, 35, and then it's going to repeat. That's what's nice about the binomial theorem. It's always going to repeat. So we're going to start off with x to the 7th plus 7x to the 6th y plus 21x to the 5th y squared plus 35x to the 4th y to the 3rd plus 35x to the 3rd y to the 4th plus 21x squared y to the 5th plus 7x to the first power y to the 6th plus y to the 7th. So one thing you need to remember, it's always going to repeat. You're going to get to a repeating factor.